And welcome back, and we're going to wrap up our talk of isotopes in chemistry and radiation and talk about radioactive isotopes and half-lives. So we'll throw a little bit of math at you. You need to be able to do the calculations to figure out how much of a substance is left after a certain number of half-lives. So the half-life is the time it takes for half of the particles or mass of a radioactive substance to decay. And if you look at the diagram at the bottom, in the red we've got the parent isotope, which will decay into the daughter isotope. So we talked about how carbon-14 will decay into nitrogen-14. Uranium will eventually decay into lead. And if you look at the picture at our original time, kind of zero right here, we have all a parent isotope. After one half-life, however long that would be, carbon is 5,730 years. Uranium can be in the millions of years. But after one half-life, we've got a mix of 50-50 of the parent isotope and the daughter isotope. And after two half-lives, if we were to count the circles, we would find that we only have 1/4 the amount of the original parent isotope left. Okay, so that's one way that we can look at it, is we can look at the percent. And so if we look at this right here diagram, it shows the decay of carbon-14. And if we look on the left, the y-axis, we can see the percent. So if we start at time 0, we have 100% of a compound. And after one half-life, we have 50%. After two half-lives, 25%. After three half-lives, 12.5%, and after four half-lives, 6.25%. So that's one way that we can look at it. So always remember, if you look here, if we start with 10 grams, we go to 5 grams, it doesn't go to 0 grams. We cut the previous number in half each successive time. Another way that we can look at half-lives is using fractions. So instead of using percentages, we can do the same things. But if we look at time 0 as being 1, after one half-life, we have 1/2 of that. After two half-lives, we would have 1/4. After three, we would have 1/8, and so forth. So you can see on the chart here, by the time we have 4 half-lives, we have 1/16. By the time we get out to 8 half-lives, we can have 1/256 of the original amount. So let's say someone told you that you had 5 half-lives, and you really quickly want to find out how much is left. Well, we know that each half-life cuts it in half. If there are 5 half-lives, then 1/2 times 1/2 times 1/2 times 1/2 times 1/2 equals 1/32. So we can use the number of half-lives to find out very quickly the fraction of the amount that's left. So using those two, either percentages or fractions, let's go ahead and let's try a few sample problems here. So the first one is, what is the half-life of a 100-gram sample of nitrogen-16 that decays to 12.5 grams in 21.6 seconds? So the first thing is, let's see how can we use this to find out how many half-lives have taken place. The numbers they gave us make it a little bit easier because 100 grams, we can just use that as 100%, and we're going down to 12.5%. So if I show you a little bit longer than it might take you, but one half-life would get us to 50 grams. Two half-lives would get us to 25 grams. And a third half-life would get us to 12.5 grams. So the first thing we need to do is to be able to figure out that there, in fact, have been 3 half-lives that took place. Well, if it took 21.6 seconds for those 3 half-lives to take place, then our half-life must be 7.2 seconds. So this looks to be a highly radioactive compound that decays. The half-life is only 7.2 seconds. Okay, our next example. If the half-life of iodine-31 is 8.10 days, how long will it take a 50-gram sample to decay to 6.25 grams? So again, we've got to figure out, okay, how many half-lives take place to go from 50 grams to 6.25 grams. So again, some of you can probably do this quicker in your head, but 50 grams will go to 25 grams, will go to 12.5 grams, will go to 6.25 grams. So just like our previous problem that happens to come out that we do in fact have 3 half-lives that have taken place. Well, they tell us that each half-life is 8.1 days. So in this case, we just have to multiply through, and 3 times 8.1 comes out to be 24.3 days. So a little bit different, but along the same lines. Okay, our third example. Potassium 42 has a half-life of 12.4 hours. How much of an 848 gram sample will be left after 62 hours? Okay, so we know the half-life is 12.4. We know that it is decayed for 62 hours, so our first thing should be, hey, how many half-lives will go into 62? And in this case, it comes out to be 5. So we have 5 half-lives that have taken place. Now, how much of that 848 gram sample will be left after 5 half-lives? Well, we could start off and go 848, cut it in half, 424, cut it in half, 212, and keep going, which would get you the right answer. But we can also use the same thing that I talked about before. We know that if there are 5 half-lives, that's going to be equal to 1/32. So multiply that by 848, and in this case, we get we get the final mass to be 26.5 grams. So that's how much will be left of the original 848 gram sample after 5 half-lives have taken place. And the last example that we'll show you today, a little bit trickier, a little bit bigger numbers, uranium-235, which has a half-life of 7.04 times 10 to the 8th years. And if 12.5 grams of U-235 remain after 2.82 times 10 to the 9th years, how much of the radioactive isotope was in the original sample? So now they're going to ask us to work backwards. So the first thing is, and I've done it already, is let's take the total time, 2.82 times 10 to the 9th years, divided by the half-life. And in this case, we get that 4 half-lives have taken place. Okay? And if we started with, if we ended up with 12.5 grams, now we've got to kind of do the reverse and double it. So that would become 25 grams after 1 half-life, 50 grams after 2 half-lives, 100 grams, remember we're going backwards here, after 3, 200 grams, and then finally after the, we stop right there. So 1, 2, 3, 4. I don't need to do the last one here. Got ahead of myself. And we would have 200 grams in that original sample. So that's 4 half-lives, and 200 grams would have been cut down to 100, down to 50, down to 25, down to 25. So our original sample, in this case, was 200 grams. So there's an example, 4 examples of half-life problems that we can use with radioactive isotopes. Thank you once again.